Okay, so we're back in the prep room for the second 4 laps, and it's because we have the IR set up. So we're going to do an IR of our starting material and our product. Remember, we always have to do the background. So we're going to go ahead and collect our background here. 16 scans again. It's always a multiple of a factor of 2. Got some. Shouldn't have any ethanol, but remember we have things like water, carbon dioxide in the air, and we're trying to tell the instrument to ignore those. Okay. All right. So we're doing a solid again. So we're going to take a little tiny bit of our solid. This is the 3-nitrophthalic acid. Put it on there. To make sure there's good contact, put that down. All right, so we're going to go collect a sample and put a lid back on. This is 3-nitro-PH. I always have trouble spelling this. PHALIC acid. Ready? We're ready. See what kind of functional groups we have here. All right. So, and as always, we are going to find peaks. Set that around there so we can see what those actual peaks are. Okay. And save that. Save this. Find it. And print copy. All right, I need to go get our starting material, our product. I'll be right back. And I'm back. All right, so we got to clean this off, and we clean this always with ethanol. Get rid of most of the materials on its own. Put a little ethanol. You have to be a little careful with that. Make sure it dries before you take the spectrum, because you will then have a very large ethanol peak, which you don't want. All right, so I just have a little tiny bit of our product here. It's on the end of my spatula tip. This is a yellow compound. So we're going to goo up the instrument, it looks like. It's mostly dry. This sample has a little bit wet. I'm having trouble getting it to be completely dry. Also, I'm having trouble getting it off. All right. There we go. Okay. Now, is that over the window? No, not quite. There we go. Okay. Swoop. All right. So now we're going to collect a sample, and this sample is going to be Luminol Mulford. Now it's time to do our other characterization test, which is a chemical reactivity test. So we're going to head back to the hood to do that. Okay, we are back. It's time to set up for our second characterization test, which is the chemical reactivity test. And I need to create 2 different stock solutions here. So stock solution A, we're going to put all of our products. So we can see our yellow product here. And I've got it on 2 filters. Remember, it was going really slow. This took much longer than I expected to dry this thing. It doesn't actually have to be 100% dry because we're going to add an aqueous solution of sodium hydroxide to it. The drier it is, the better the IR. Let me get out of it. Okay. And then our second one. It is a little bit gooey. As was, I dried this for about half an hour on the vacuum filter. I wonder, given how much material I have here, it still looks like it's the right amount for a Hirsch funnel, but I think an Buchanan might have worked a little better. All right, so we've retrieved most of our material here. or enough to get the duration to go. All right, now to this, we are going to add 2 milliliters of the 10% sodium hydroxide. So again, strong sodium hydroxide stuff. 2 milliliters. We have a slight mixing problem there. I'll deal with that in a second. Okay. And then we also add to this 10 milliliters of water. That will help us a little bit. Because it's going into our reaction flask, of course, we use deionized water. Knock that stuff down there. There we go. A little bit gooey, but okay. We'll let that sit for a minute. You can see the solution's getting yellow. It's going into solution there. There we go. That's what I want. It hasn't quite all dissolved yet. I actually got a good yield there. So we should be able to get a good reaction here in a minute. Now, this is more concentrated than we want for the reactivity, so we're actually going to dilute some of it in just a minute. But I'm going to give it some more time to dissolve while I prepare solution B here. Go ahead and clean this off. Okay. And solution B, or stock solution B, is a couple different things. Potassium ferrocyanate, potassium ferrocyanide, KFE, with 5 or 6 cyanides on it. Though I noticed that the label here is wrong. That 6 should be on the outside of the parentheses, not inside the parentheses. Whoops. Okay, but we are going to put in 4 milliliters of this. And I'm actually going to do this twice so that I can run the characterization reaction twice, just in case something funky goes on. It's always good to be prepared. All right, so 2 milliliters and 2 milliliters. That, and I have to be honest, this reaction is just fun. And so I want to be able to do it more than once. Okay, so there is our potassium ferrocyanide. Now, this is our oxidizer here. We've got 3% hydrogen peroxide. Made this up fresh today from 30%. So once again, 4 milliliters of that. Okay, and 32 milliliters of water. Seems like a random amount, but that's what we need. Somebody spent a lot of time running this reaction, optimizing that. There's 31. And there's 34. Very easy to deliver. I'm a waste speaker for that reason. There we go. Okay, we have lots of yellow compounds here today. All right, let's get another 32 milliliters. Ooh, I'm good. Okay, 32 mils. All right, so we've got stock solution B. Okay, so now we're going to do our characterization test. We're going to do a reactivity test. And I have my assistant here, Theo,
Hi.
To help out. And so he's going to go ahead and pour solution A here into solution B, which you probably can't see very well. But he's going to go ahead and do it. We're going to see what we get. So go ahead and do it. Just pour it all at once. And move your hand away so people can see it. Oh, look at that. Is it showing up? It's kind of showing up. I'm going to bring it up. If you know, there we go. Nice and close to the camera there. We made luminol. Okay, so this is a chemical reaction where the product, or one of the products, is energy and light. So we're definitely getting a glow there. It worked! The professor can still do science. Yay! Okay.
Yeah.
Now, as I said, we were going to try to test this 2 ways. I'm also going to try the more concentrated solution. I don't know if this is going to make a huge difference, but we're going to try it. So, Theo, can you go ahead and pour that one in? So this is our second test.
So, smaller into bigger?
Yeah. Mm-hmm. Oh, that's a nice break. Oh, move your hand for a sec. Okay, you can kind of see we haven't mixed yet. So we stir. Yay! What do you think, bud?
Yay, I like it.
Science! All right.
Oh, we left for like 3 minutes.
Okay, and so we're just going to let that go for a second and glow. I sure hope that's the recording.
Yeah.
All right, we still have some dim glow here. Ooh, nice bright blue. This is a little different than the reaction that they use in glow sticks. That's called the Silume system, which is similar, but it releases more energy for a longer period of time, and doesn't have the hydrogen peroxide, which is, well, causes burns. In fact, most of the holes in my lab coats have come from hydrogen peroxide. All right, so that is it. We have made luminol.